All right, thanks for being here. We're going to talk about the commutative and the associative property now. I've been trying to make this video. This is the third swipe at it, and I keep running into snags and people calling and crazy things happening. So hopefully we'll get through it. So commutative and associative property are some properties you should be kind of familiar with from earlier. I believe 5th and 6th grade you kind of cover these. Commutative property basically says that when you're adding numbers together, you can move them around and you'll get the same result. Same thing with multiplication. So it applies to multiplication and adding. So a good way to remember that is the first two letters of commutative are C and O. So if you can think of change order, right? Change order, the order changes. And then like an example of commutative property would be, if you have 12 plus 12 plus 6 equals 6 plus 12, and most of you look at that and you go, duh, that's easy, right? So that's kind of what the commutative property looks like, real simple. Associative property is all about grouping, which is what I got written up here. It's all about like how you decide to do something. So for example, if you've got supposing you've got 2 plus 7 plus 3, right? You can, and you're thinking of it like this when you first start. Well, there's nothing that says you can't think about it like this instead. And the advantage of thinking about it like this is then you get a nice easy number to work with. You get 2 plus 10. And even though we're looking at, and not that 9 plus 3 is that difficult, but 2 plus 10 is easier. And so I think it's about using this property, and then you'll use this in conjunction with other properties to make it so you can do more mental math and find ways to save yourself some time. And just that's kind of the whole goal of this. So let's look at some examples. So we've got number 18. We've got 11 plus 7 plus 5 plus 13. So the way we can use these properties is I look at this and I say, you know what? I know if I add 7 and 13, I'm gonna get a number ending in a 0, and I want that. So I'm gonna do that. I'm gonna leave 11 here. I'm gonna go plus 5, and I'm gonna go plus 13. I'm gonna put that 7 all the way at the end. So I use the commutative property to do that, right? And then I'm going to group them specifically a certain way using the associative property, right? I'm gonna group them like this. And then when I do that, 13 plus 7 is 20, and then 11 plus 5 is 16, and that's just substitution. And I'm obviously combining steps here, but I want to just kind of get the idea across to you. And then 16 plus 20 is, I think, a lot easier than just going, well, you got 18 plus 5, well, it's 23 plus 13. And you get to the same spot. And even though I can do this pretty quick, a lot of students, in late middle school, early high school, they still struggle with that and can't do that quickly. So I like this because it allows me to move the numbers around how I want to work with them. So let's look at this example. This is kind of a weirder example of it, but I'm gonna try and multiply all this together. So in order to do that, the first thing I gotta do is I gotta put these things in terms of improper fractions. So you have 11 fourths, then you have 9 eighths, then you have 32, and you're going to kind of see. So the way I think it makes the most sense, if you look at this, instead of multiplying, I should multiply these two together. So we're talking about a grouping thing. And the reason that is think about what your denominator is going to be when you do this, and then think about what we're going to be multiplying it by, right? So 11 times 9 is 99, and then 4 times 8 is 32. And then you're taking that and you're multiplying it by 32. All right, so this we just use associative property, right? And then we use substitution to get it to 99 over 32. And then if you look at this 32, right, and we'll call that 32 over 1, let's think about splitting this almost mentally as 99 times 1 over 32, right? And then you've got that 32 over 1. Well, that's a multiplicative inverse you've got going on, right? You've got this times this, and what happens when you multiply those by each other? is they cancel each other out. And actually we'll use it with the one we got written here. So those cancel each other out, and you wind up getting a pretty easy number. Now, if you would have been able to do that in your head, probably not. But this is a lot easier than just taking all this and just 99, 32, and then multiplying 99 times 32 and then dividing it by that's silly. When you don't have to work that hard, you absolutely shouldn't. Okay, so let's look at one last example, or two last examples. 21. Decimals are a great example of being able to use grouping and commutative property. So like how I would do this one is I would say, well, I'm going to add these two together because that's going to give me a number that's just a whole number. So 2.4 plus 3.6. Well, 2 plus 3 is 5, but 0.4 plus 0.6 gives you a whole. So you get 6, which is sweet, right? And then you have 4.3 and 9.7, and that gives you 14 using the same logic, right? 4 and 9 is 13, and then 0.3 and 0.7, 3/10 and 7/10 equals a whole, right? So you have a whole plus 13. Then you have 14 plus 6. You have 20. And if you're kind of organized, you know, you can do that a lot. And that's a lot better than going, all right, 4.3 plus 2.4. Well, let's see, that's 0.7. Then adding 3 points. You know, that's lame. This is so much faster. It makes more sense. It shows that you've got some number sense, and it will save you a ton of time. All right, last thing. Raphael is buying furnishings. All right, so, you know, furniture and stuff for his apartment. Buys a couch for $450. Lamps for $55.50. Rug for $43.50. And a table for $75. Find the total cost of these items. Well, this is another example of what makes the most sense to add up. Well, instead of going left to right, why don't we add these two things that end in 50 cents up together, because we know that's going to give us a whole dollar, right? And if I do add those up, well, 55 and 43 gives me 98, but then if I add the 50 cents together, right? 50 cents plus 50 cents, that's going to give me 99 bucks. And let's do 450 and 75, because most people can kind of figure that out, because 450 plus 50 is 500, and then you get 525 because you have 25 left over. And then plus 99, well, the easy way to do that is just think, what's 525 plus 100? Well, it's 625, and then just take one away. Then you have 624. So 624 bucks, right? So, you know, these are all ways in which we use these properties, and maybe don't think about what we're doing or put a name to it. But they are very useful, and I encourage you to try to think about that as you're using those.